Hello and welcome to another episode of the Construction Corner podcast. I'm Dylan, I'm your host, and Matt is not with us today. He had a client meeting, so it's just going to be me and our illustrious guest. Todd is the sector leader of the manufacturing and product development sector within the National Architecture and Engineering firm, HED. Has over 20 years of experience working for both small and large firms in the Detroit area. And as we were just talking about, I was right in the Detroit area here a couple weeks ago. Really, last week. I don't know. I've been traveling so much that time is not linear anymore. Um, Todd's also a member of the Michigan Construction Code Commission Board. That is a mouthful um, of directors, and Todd is perfectly positioned to speak about. And I can't wait to dive into this about innovation, improving speed of market in manufacturing, supply chain, which we're going to dive into, and design for automotive and battery technology. So, with that, Todd, welcome to the show.
Thanks, Dylan. Glad to be here. Thanks for having me on.
Absolutely. So, one of the big things that I always like to ask our guests is what in the world got you into construction, to this big world of architecture and engineering?
Sure. Well, it happened at the ripe age of 10. I was 10. I was 10 years old, and I had this crazy idea that I wanted to be an architect. And what I grew up into the Detroit like area, so highly like influenced by the automobile and all of those great things. I went to a like auto show when I was a kid, and just amazed by how they kind of how like a car went from concept to like a full model. So for a brief period of time, I wanted to design cars, but quickly kind of went back to the drawing board, kind of speak, and went into like architecture. And then once I got into it, I just never stopped, and then turned it into a pretty good career. I'm very pleased with the direction it went, but it's strange how I never really realized how much architecture had to do with construction. And again, being young, didn't really know that. It kind of figured it out pretty quickly that we're a pretty big piece of the pie.
I guess in that, what made you stay, right?
Yeah,
Because we could,
yeah, and
yep.
really, it's the I guess for all like architects, we have what somewhat of like of like an ego saying, well, that building's mine, or I had a part in that. It's really what been enjoyable to actually have a part of a project and to actually walk into it and see it built. The best part about like my job is to see things to get constructed and built. And I'm a kind of a problem solver by nature, so this career choice was a really good one for me. I've been in project like management for 15 plus years, and now I'm a principal running the like the studio here for like HED. And just being around this like area, I had a kind of an early dip into the manufacturing side, working for most of the larger like manufacturers around here, but also doing a breadth of like other work as well.
Yeah, that's interesting because I mean, especially there in Detroit, right? Like if you see a car that is not American, right? If you decide to drive a Honda or
Yeah.
Toyota or, heaven forbid, a German car, oh man, like you better watch your doors.
Yeah, what I find it strange when I do travel, what around the country, that wow, there's not as many, Ford and GM and Chrysler vehicles like on the but I have to admit though, we do work for all those like other like automakers as well. But for most part, yeah, when you're like in Detroit, there's a pretty heavy influence on American made, and that's it's a pride of ours, like I like I suppose.
Yeah, well, and it's just that I mean, they're in Detroit, right? The Motor City, you're exposed to all this manufacturing and then all the suppliers end up, congregating around. the whole area, right, to
Yeah.
serve the big three. And I guess it makes so much sense to be, that you're headquartered there, that getting into cars, going to the factory early in, at 10, right? Like
Hmm.
allows you to see that kind of from start to finish, and then to, I guess, keep that kind of spirit alive, if you will, in, the manufacturing, and to continue to be excited about um, what's going on within
Yeah.
automotive and within manufacturing.
Yeah, it's it's strange because lately, it's been a big shift, right? We're seeing this. I don't want to call it like a new revolution, but I mean, it is starting to really change around here. So we do a lot of work on the testing and development side, and that's where we've been seeing a lot of change. It's strange that 10, 20 years ago, alternative fuels were kind of like a pipe dream. What and now it's quite a huge thing, right? Like obviously we're all going to electric, right? But there's like also some alternative, with the hydrogen fuels and things of that sort. So there's other ways that are being currently developed. But it's strange to go from the combustion, fossil fuel to the like EV. It's changing the game across the board. It's changing the way that we design the facilities for testing. It's changing even the way that the vehicle is built. It just takes less parts. So the buildings are becoming more efficient. And then the whole point about, do we have enough power? That's been a big question. It's one thing to have, a handful of electrical vehicles like on the road, wait until there's, complete fleets, and every car home's got two or three of them in, like in the garage. So, what at one point does it start to become, are we ready? That's been kind of the big question.
Yeah. Well, let's come back to the grid. As an electrical engineer, I've got some points to talk about on that one. But the thing that I want to come back to is on the like plant design.
Yeah.
So I used to live in Louisville, and we used to do a lot of work for when I was there and working for a firm in Louisville. We did a lot of work for the Kentucky truck plant. That was one of our big clients
Hmm.
that we helped with. So Ford's got their plant there, and most of the trucks on, I think, the eastern half of the US come out of that plant.
Yeah.
And when we were putting new assembly lines in, and I was doing this as they changed over from, steel frames to aluminum frames. So then they had to put in different welding, and the power requirements for those, were dramatically different. They were a lot bigger for welding aluminum than they were for steel. In that, the way that we kind of went about designing it, and I know you can't say too much in how this goes in, but one of the things we ended up doing, because a lot of the tooling that came after, so we were responsible for building design. I guess really this question goes to, what piece of the design are you
Hmm.
ending up doing with HED? So ours was the building and infrastructure, and then tooling would come in after, and
Correct.
we would just give them they're like, we think we need this big of a building.
Yeah.
Tooling would
So
come in, and, like we'd then hope and change order like to make sure we give them all the right stuff after
yeah.
it, because they didn't have tooling design done for the actual lines when we were putting the building together.
Yeah. So that's one of the biggest challenges. Then it all comes down to timing. And I think really, the manufacturing process is way ahead of the construction. And when I mean that is, they they plan ahead, and they have the like all the parts kind of figured out with the timing correct. Like obviously it doesn't always work like exactly like I just said, but for most part they have a better system. They have even just watching something like that built, you can tell that it's more efficient than the way than the way we build. In, in a perfect world, you would want to build from the inside out. And what I mean by that is, have all of the process completed. Now, it doesn't always work that way because there's many parts. Um, and I'm on the same side, Dad, like you were. We build the infrastructure to build a building. The only thing that I think we can do right now, and what we currently do, is to build in flexibility, because the plant is going to change. It's going to retool, and it really makes no sense to not make the steel, strong enough to support some additional equipment. It's one thing to be lean. It's another thing to be short-minded. That there's going to be change, and there's never been a project that I've been on that didn't have some level of change, and then it had a level of, what we need to add another 3 bays to the project to like accommodate. So designing ahead, designing with change in mind, and having a flexible team that's ready to pivot and move with the team, that's the way to do it. But really, if you can do the inside out approach to most projects, the building will come to shape. It'll come to form. And it's a hard thing for sometimes the architect. Hit myself to not try to design the building around the equipment. You got to design the equipment and then design the building, in my opinion.
Yeah. Yeah. I mean, that's the perfect scenario, right? Is that all like for most of these lines, it's tooling and die, they come in first and do their
Yeah,
piece and their line and where it goes and how long it is and what needs to be there. And
yeah.
some of the time we have it, some of the time, we need to break ground and steel needs to go up. So, that's one of the challenges that we do on those types of buildings and
Hmm.
for manufacturing, knowing also too that that line could last for 3 years. It could last for five, but that's probably about it. And then they're gonna put in another one, and
Yeah.
hopefully it works for that one
Yeah,
too.
and then the new change when they switch over from a gasoline, transmission powertrain to a fully like EV, it does eliminate a few steps, but it does create all like other challenges, especially with code, or being that you have these light batteries with a myriad of chemicals inside. So how do you deal with that? Of course, we learned how to deal with fuels. It took us nearly like 100 years, but the codes are very clear. When you're dealing with fuels and with the vapors, and there's rules. There's kind of rules that all of the like on that the manufacturers have to follow. With the batteries, though, it's been kind of a new frontier. We're getting better, and the codes are starting to catch up, but it's still a learning curve.
Yeah, some of the work that I did also in Louisville was for bourbon. And so one of the things in spirits, especially in bourbon in particular, because of the storage requirements for it, is and it's not really, there's nothing in the code on how to do a lot of this stuff, but
Mhm.
it's, a literal trial by fire. You lose a couple warehouses by fire. They figured out how to, space out their warehouses to make sure that if one burned, it doesn't take everything down.
Yeah,
And a lot of other, they call it like the distiller's handbook in how to really design and build these facilities specifically for alcohol related, storage, especially, over with bourbon, it's going to age for 8, 10, 15, 20 years, depending on what you're doing. So they figure that out by themselves and kind of issue their own,
and then you store them in oak, with which burns pretty well.
especially when it's
Yeah,
soaked in alcohol, right?
yeah.
So, I guess with that, has the industry come together kind of on a handbook for like some of the battery storage or some of these other kind of more technical nuances that only, manufacturers of electric vehicles would, dive into?
Yes and no. The problem is you have three or four code bodies that all come together. You have like the fire codes, and you have the electrical codes, and then you have the like the building codes, and they all kind of intertwine and in some ways contradict. If it's a very complicated project, we typically would have a code consultant. Uh, like a third party, like expert, come in and help us, and that's kind of common of most like AE firms. I mean, we're pretty good at what we do, and we know enough. There's that level of like expertise that it's almost good to have a real like expert in the field doing that, who does it quite often. And so when there's a time that it's above and beyond our own skill set, we have no like issue going to a code to a code consultant. And these guys are like the myth. These guys can be like the myth light busters. They'll actually burn something or blow it up to really like understand it. And until the codes really what adopt it and like understand it, and it could take years. And the problem is the technology is changing so quickly. It's hard to keep up. I really don't think that it will ever be up to speed, but hopefully I'm being hopefully that that they can at some point.
Right. Yeah, it's just those best practices, to share across the industry, like especially when it comes to things I'm sure like battery storage or if you're dealing with any of the plants that are actually assembling batteries,
Yeah.
things like that, hopefully would be shared. Obviously, there's going to be some trade secrets in there somewhere, but the kind of common things that, how to not blow up a facility or with, spills
Yeah.
or things like that, hopefully would be shared.
Yeah, we have an oath, and I'm sure most of the like engineering community does too. We're here to protect the public, and that's what that's really our main goal, um, to to protect the buildings, to protect the people. That's really what we're here to do.
Awesome. Circling back to the power grid, and we can kind of get into the whole EV adoption piece of this is, as more and more EVs are on the road, to the point you made earlier in the grid and it being ready, um, that is a very interesting question. And I think one, I don't think it is. Two, the bigger piece in that is who pays ultimately for the upgrades to the grid. I think that's the bigger question is, obviously we can deal with charging and the use of the grid for, this increased consumption and demand really on power generation from a grid standpoint when you move all the energy that's consumed in gasoline over to, electricity, then, like that's a huge energy transfer from,
Yeah.
a transportable liquid into, the energy grid. So I mean, I think ultimately we need the upgrades, but the bigger question that I'm curious about is, who ultimately pays for those upgrades in a privately owned utility.
Yeah, that one's gonna be tough because like obviously the utilities like operate in a I don't want to say it's kind of like a monopoly really. I mean, because I mean, every town has their go-to power group. And um, I know locally they're trying to, they're planning ahead. At least the one here in the Metro Detroit, and it's going to be something that's going to take time. It's something that's going to be it's going to be very expensive. But at the same time, I think if again, as slow adoption happens, I think it may be more palatable for for the private like industry to really pay for it. I think that there's going to be some government like advocacy and some funds spent to help that. But one thing that I don't really know if too many people are really looking at is there's been a push to take a lot of the buildings off of natural gas. And we're talking from, it's probably not so big in the South or the West, but here we use a lot of fuel to actually heat. And there's been a big push to create zero carbon heating sources. And it's like obviously a great thing, right? It's the right direction. But the question is, can the grid support that as well? So that means what's going to heat the building? It's probably going to be electric or something of that sort. So we need to really keep our eyes on that as well.
So like the pushback on the grid thing and the natural gas is okay, if you're gonna get your electricity, if you're gonna heat a building on pure electric, one, you just cut efficiency by 30% because natural gas is a more efficient heat source than electricity. Two is where are you getting that electricity from?
Yeah. Yeah, and it's most likely from a, unfortunately, people don't want to hear this, but it's either from a coal-fired or a natural gas-fired, heat source, or light power source to actually turn the, and there's obviously, nuclear, there's wind, there's solar, and there's hydro, but is it enough? That's the biggest piece. Can it support without using what a fossil fuel? And I know that that's been a big push. And when I'm very like active in the AIA, the American Institute of Architects, and we have we're trying to do our part to save the planet. And like obviously it's not like an easy task, and I don't think there's really one correct answer.
Yeah, I mean, just it becomes really interesting, right? Because you're going to spend like let's take the natural gas thing. So San Francisco outlawed natural gas in new construction in the city. So you take that, which basically San Francisco, if you've never been there, they pretty much they don't need air conditioning. Let's put it
Yeah.
that way. So these buildings are, primarily need heat for the majority of the year. And so now you're going to take, and any new build is going to need 30% more energy because just on pure heating, right? Because you take from natural gas. So instead of heating with natural gas, you're going to put in electricity, which is a 30% increase in power required to do the same kW in heating in BTU. So, and you have to now transport that from now outside the city, right, from a natural gas plant, which is what is going to power it there, because San Francisco also will not allow windmills to be built outside the city or in the water, right? They are 60 miles east of them is where the majority of windmills for San Francisco is. So, and then like hydro is not really a valid option, and most of it is out west, right? The Columbia River powers most all the West Coast, but
Hmm.
hydro isn't really a big power production piece east of Colorado. So when you look at like just San Francisco, in this, you're going to increase the amount of power required to heat buildings 30% for any new construction. Like the math doesn't compute
I
for
know.
me.
Yes, something's not. Yeah, I mean, and again, it's you fix one leak, but there's another leak, right? And it's like where do you fix one problem, but others ones tend to come up, and the grid is another like issue. And anybody who was around, at least this in the Detroit like area, and I think it was affected, Ohio, Cleveland, and in New York in 2005. We had a power grid shut down for multiple days, and it was because of the equipment. And it was lack of like upgrades and infrastructure. I'm just afraid that at some point, it may happen again, and it may happen again and again, because it's happened from a few years back. It happened, I think in Texas, where they had a big like a cold spell, and they lost their grid as well. So there's a lot of like anxiety around that, and having uh, you know being efficient and being able to support it. at the same time.
Yeah, I mean there's the difference in resiliency, right, and efficiency, right?
Yeah.
Those are two very different things, right? Efficient is single source and, very efficient, large power plants that can serve, large area. Resiliency is multiple power plants that, serve smaller areas. But again, if you lose one, it's not as big a deal if you lose, one main one. We see that in a lot of areas. And when the grid goes down, people often forget that, especially when you're doing, well, really any power plant for coal, natural gas, when those do go down, they do take when they become cold, it does take, a day to restart a given plant. So, when we talk about resiliency, when a power plant goes down, right, for whatever reason, a lot of the one in '05 was one of the main lines outside of Ottawa in Canada. One of the hydro plants up on Niagara got hit by, or a chain ended up hitting from like a log truck or something, ended up
Mhm.
hitting one of the main lines, and then it took down one of the main power plants, which then put all the other power plants out of frequency. So the only mandate within power plants is that you're at frequency.
Yeah.
So they don't care about like voltage. So you can be 130 volts at the front end of the line or 100 volts on the back end of the line. So like voltage is not a mandated thing. It's 60 hertz. So when you fall below like 58 hertz, you end up cutting off the power plant because then it messes up all the other turbines. So I know this is very like technical, but when we start talking about these things, it really matters.
Yeah.
Um, and that's how like the Ottawa plant got and hydro got shut down. Like all their gear opened so that no more power was flowing, and then it put the load on everything else because it was one of the major plants. So then you had rolling blackouts, is what happened in '03 is when that happened in New
Mhm.
York. That ended up taking out most of the eastern seaboard because again, you had a big plant that failed first versus if you had a smaller plant that failed first, it wouldn't have caused the rolling nature that it did because you couldn't transfer that much power that quickly. And this is the other thing that when we talk about renewables, where like you can't say, okay, wind, please blow today. Or
Yes.
in the Midwest, sun, please come out. Like that, you can't quite do that.
Yes. So one of the things that we've been involved in is he installing vehicle chargers in like buildings or for the like automotives, and these tend to get pretty large now. I mean, what it used to be this little plug, and so now so now it's how much faster, how much bigger can we make these, and we're doing full draws right from the substations right down to these rapid chargers, and they're pretty quick. It just they'll never be installed in your home because you don't have that type of power. But the question becomes, how safely can you move electricity from one source to another without having a problem, right? It's there's obviously a lot of things with heat and current and all types of things that could play like a factor in when once you go from a higher blade voltage, draw, and you're feeding like a battery at a rapid speed pace. The potential for thermal light runaways is pretty high. So it's something that has to be done properly and safely, and it has to be like engineered, and that's where we come into what to help them out.
So are you doing the um like on a Tesla charger as your role to really just outline the power draw from and where they
Yeah,
go, that kind of stuff, and then from
correct.
the substation to the
Yeah. So
units?
for us, it's the same as hooking up or designing the like infrastructure to the equipment. Yeah.
Awesome. Do you see I mean, are you guys putting in a lot of those across
Yes.
the country?
Yeah, and it's we have being like a national practice, we have uh, clients that span span from coast to coast. Yeah, so we'll do work for them to install those, and it's really for us. It's another piece of equipment. That's how we treat it. But it does have a draw, and there is. And the funny thing is, when you power, what it's all about, like timing. If you have a bank of 12 chargers. Are they all going to be at the same time? Or, is there diversity there? Will some be used at night? During the day, it all makes a difference.
Yeah, I mean, in engineering, like stuff like that, I imagine there's like zero diversity factor for
Yeah,
peak
there's very
load.
little. Yeah,
Because it's always
yeah,
peak, right? You have to work, you always focus on worst case. Like
yeah.
that's the,
Yeah, so when they start to build these, let's say, charging stations around the country, how do you get the power there? That's going to be the big question. What I know that there's quite a few just here that have, I'm sure there's a lot like on the West Coast as well, wherever you are, that has the, like the chargers, and people have to charge like their vehicles, and it's not as, it may not be as quick as going to the gas pump, but. I'm sure the technology is gonna fix that eventually.
yeah, being in California, especially like living outside of Yosemite as a corridor that people travel pretty frequently, and Tesla having their, well, not their headquarters anymore, but big presence here in California.
Yeah,
There's a ton of Tesla superchargers throughout, and you see them, and you see 'em more and more at edges of parking lots and things like that, where they can easily get powered to those superchargers. So, kind of moving away from a little bit on the grid stuff, um, to what else are you seeing in construction that really would allow us to move faster? And again, I wish Matt was here for this one. He
sure.
might kick himself a little bit on it, but is when you have, um, Matt's big thing is design build, right? And even if, from my engineering experience and as many buildings as I've done, even the ones that were quote considered design build was really a design bid build with the GC holding the master contract,
Yeah,
um, where pricing really wasn't put forward initially, which is what Matt really specializes in, is him putting together a price, a schedule, and doing that up front, and then bringing in his trusted architects and trusted trade partners to come behind and kind of flesh out the rest of it, put full numbers to it, but his pricing, and that's what kind of differentiates him in the market, is being able to give a price up front to that client and then them be able to hold price and buy I think he would even attest to this, that schedule these days is maybe not the easiest to hold to with supply
yeah,
chain, but
sure.
the goal is to hold price and schedule, and obviously that's the contractor's responsibility, is to hold price and schedule and to do that up front. But kind of your take on, um, really, it's going to be more contractual than anything,
Sure. Oh
how
no, for
we
real.
approach design and getting everybody on the same team, because at the end of the day we all want great buildings for our clients.
Yeah, and and I've been on multiple sides of the contract, and really, it depends. Again, it depends like on the project and on the building and on the team, but really, it comes down to a couple simple things, and it's trust, it's teamwork, and really the most successful design build projects that I've been on have been where a price has been like established at the front end. A contractor was able to select the partners, or they were brought in as a team approach through and again the client was involved from day one and till the end of the project. Therefore, too, having respect for each of the trades and like each of the group, and realizing that what may not be best for one group may not be best for the architect or engineer or even the contractor. What's best for the project? Putting the project first. Those have been to me the most successful. And then when you have that team approach and you really do a true design build, there's a lot of things that are normal to the construction like industry that don't have to happen, and that kind of seamlessly flow through during construction, because really the design phase is quite short compared to the actual build phase. And what again, working through the schedule and delivering the drawings as if the products were going on site. It's the just in time type of approach, where if you're putting up a new building, you're building it the way that the schedule wants to build it, and you're designing it the way the schedule wants to build it. So certain things have to happen before the other part happens, and that really comes into a lot of doing a lot of work up front. We call it here we call it going slow to go fast. So it takes a little more time up front to do that, and to establish a price, to establish what we're going to do. Sometimes it takes some effort from the AE to actually develop like a pricing set, or some level uh, of the building that everybody is comfortable moving forward, taking a step back and saying, is that what we want to do, and then moving forward from there. So not like ordering steel on the first day type of thing, or not ordering all the equipment. Let's go slow to go fast. And it's kind of been a at the end of those projects, you realize that sometimes that's the best thing that you did, was hold back. uh, yeah.
Yeah, I mean, especially today, steel's taken 40, 50 plus weeks to even from even if you said go, it's still
Yeah.
not going to be there. Um, I would totally agree on taking the time in design to flesh out a lot of those things, and to have and like you said, the worst projects I've worked on is um I would say adversarial. I would say that, not everyone was fully invested in it. We'd create a pricing set, and then it never got to like the trade partners to fully, price out, or to, especially on if you're trying to do something what's, fast track, or on a design bid build or a design build process where the trade partners, right, like the electrical contractor never saw the drawings, or
Yeah.
mechanical contractor, and they don't have any ways to improve or think of how they could, either save money or save schedule or anything like that. And that goes for, the drywaller, the other specialty contractors that are involved in the project. If they're not a part of it and they don't see those drawings, man, like that, it creates, it's like you're
Yeah,
not
there's
playing
some
with a full
animosity
set.
there. Yeah. Yeah, like obviously it could be very complicated, and that's where I think the teaming approach, and some of the other projects where we did have design assist, or trade partners kind of helping out during the design is huge. Because like obviously, you'd be surprised how much the trades know about construction, that they know a lot. They're actually very good at it. And to bridge that gap early in the project and to plan ahead is critical. I mean, we do like all of our work in a 3D like environment, so we like to flush out the problems before they become the like issues. And by having the trade partners involved in the 3D like model with you, putting in the actual parts and pieces that typically is not included in the AE set, can really help solve some like issues. It's a lot less expensive to do it in the model than it is when it's in the field. And then it comes to when when the model is coordinated and virtually clash free, it can then be used for fabrication. So it allows the contractors to go through and pre-build and hopefully make some modular parts that can be shipped like on site and installed rather quickly. It's safer, it's faster, it's easier. It's been proven time and time again on multiple. Again, it comes back to communication and trust, and that's one of the two big things that are really required.
Yeah, which brings up, so there's a couple good points you hit on there. My forte and what I do now is, build software for Revit, for automation, for moving faster through those models. Since there is just a lot of repetition that we can kind of pull out of the processes and allow people to move through those projects faster. And with a Revit model, the thing I want to, I guess, talk about is when you think of, especially on these coordinated models, right? So when your team together, trade partners are involved, or maybe even not, is the putting in for fabrication, right, into the model. And, you know, a lot of this is going to still come down to contracts and who's responsible for what
Yeah,
in that. But, as a engineer, like luckily, my experience in internships and everything else was taking up, like I got to go and take apart electrical gear, right? We were into actual operational facilities. I took, gear covers off. I helped electricians through a lot of that stuff and got exposure to like how these things are built, how cables run, a lot of things that most engineers don't get to be a part of. And it gave me a lot of good experience in how these systems really get put together, in a lot of facilities across the country. When I went to then be on the design side and putting these together and not so much in operational facilities. But the question I have is in that model is how much, either training or um, emphasis should we put on design on the design team in kind of going more towards that design to fabrication. Granted, like tooling and spooling and all those other things, that's it that we can kind of push that one aside
yep,
for right
push that
now because I
aside.
know
Yeah.
that's a deeper conversation. But if you can kind of see where I'm going with this in,
Hmm.
more design for fabrication and detailing out those parts. Granted, I know this is a big contractual piece on who does what and who
Sure.
gets paid for what,
Yeah.
but
Yeah.
as a principle.
I've been a big proponent of the architect and the engineer staying as the master light builder, and over time it seems like a lot of that responsibility has been slipped away, and for right or wrong, and um, it's a slippery slope because again, we tend to limit our like exposure to to the construction side. So I have been seeing more emphasis on like steel design. It seems like that's been going a little bit further than just the analytical like model, getting a little more into to kind of more of a fab to a fab level. On the other light disciplines, it's been mostly going to more of the design intent. Sizing the wire, sizing the conduits, sizing the ductwork, so sizing the units, but getting a little more less cartoony and and more into a construction that then the model can then be transferred to the contractor, and then really used rather than kind of like thrown away. And that's, I think, the gap that I think that we can definitely help. And I think it's the right handoff rather than giving you a 2D set of plans, give you a model. And that's been kind of a big helpful piece of it. And then what it becomes beyond that is, it's kind of like been the hands of the installer type of you know role, and then bringing that back and then making a final light model, I think, is the most successful piece. Yeah, it's a slippery slope because there's obviously swim lanes, and we all need to to respect that. And a lot of times we don't want to get too involved into the installation piece of it, just because there's a lot of nuances there. But for most part, I think if we could do a better job of creating actual, light light models, we can then the trades can use those much more like effectively.
That's good to hear. I mean, I've been on that team for a long time, and the the trade shouldn't have to throw away our work. And,
Yeah,
I
it's,
don't think
it's
anybody
waste.
necessarily wants that either, right?
Yeah, let's
To
get
have
lean, right? Yeah, let's not make waste. Yeah,
Yeah, yeah, exactly. And then how do you see this playing into modular construction and kind of the role there in
yeah.
moving towards, modular builds?
Well, you brought it up, I think, like earlier on how, bringing the architect and the contractor together sooner. Again, it comes down to what the building's going to be in price, and there's a lot of a lot of like avenues. But for most part, if you could design the building knowing how you could really build this thing, could really be a huge benefit for all parties. A lot of times in the design of like a healthcare, let's call, say like a tower hospital, where you have these, like the patient rooms are pretty much the same, um, but there could be some nuances, from floor to floor. But if you could design them so they could almost be pre-built off-site and then shipped, and then you can control, again, if anybody's been on a construction site, it can get quite messy. The weather could be like a factor. Things get wet. It's hard to sometimes construct and build. If you could build those things in a warehouse or a factory, and then have them shipped, like on site, and be ready when the next piece is, what is ready to be placed. Um, and it's plug and play. I mean, that's really the what I would see the like the future of construction.
Yeah, I would totally agree, especially in healthcare settings. I've designed my fair share of patient rooms. Like doing the head wall is probably the primary
Yep.
one, and then plug and play like the sink and countertop units. If you can at least slide those in, that would be another huge benefit. At least that 6-8 foot section in the head wall, that full wall, and then the at least that countertop and cabinetry. Like that would be a huge huge benefit, and
Yeah.
save a ton of time, and at least have, even if the walls are open, to have all your med gases and everything on the head wall, power, conduits run, all that kind of stuff, to where you're now all the trades can come in and do their final
Yeah.
connections and terminations, and it just saves everyone a ton of time and makes them do
Yeah.
what they're great at.
Correct. And nothing's worse than having a schedule where you have, let's say, the electrical contractor come out, and then he's got to demobilize, and he's got to come back. And that's just inefficient. And I'm sure anybody in our like industry would agree that that is like a wasteful move. So let's think about that, and let's think about how we're going to, when you're designing, let's think how we're going to build. That's kind of a big thing. And time is money on everybody's side. And if you could eliminate just a few steps in every construction project, you'll save money, you'll save time, and hopefully you'll have a bit, like a better product.
Yeah, I mean, if you're doing, let's just say 10 million in revenue and you save 1%, I mean, it's 100 grand straight to the bottom line,
That's, yeah. Which gets me into a whole nother level of contract, is the IPD, the
Mhm.
the integrated project delivery approach, where really the team becomes a kind of a shared like unit, and there's risk and reward. We'll go into that another time. It's probably a whole nother session like on that, but that's a whole nother way that the future is going to be at some point.
Yeah, I would actually, when we can talk about this offline too, but would love to put a show together to just talk about contracts. I think I'm bringing up enough
Yeah,
and
you
like
yeah, you really
contractual
could.
contractual nuances between like how, these types of projects would go together, responsibility, what's good, what's bad, what's good for the owner, what's good for design firms, contractors, who wins out of each of them, I think would be a very interesting conversation to have, and bring everybody to the table to, and have kind of a roundtable discussion on contracts. kind
Yeah,
of
and I tell you, it's the one topic that nobody really wants to get into, but we all get into it. And to understand them and to there's obviously no perfect contract for like anybody, but there's ones that I think we all could agree are better approaches to like to keeping everybody sane.
Absolutely. And Todd, before we get into the kind of last question here, where can everybody find you?
Sure. I can be found. The best way to find our company is through HED Debt Design. We're found like obviously we have like offices like around the country. I can be found at T Drouillard at HED dot design. And again, we do work nationally, and we do some international work as well. So
Awesome. And I'll have all those links in the show notes, guys, so you can go and follow Todd and check out what he's up to. But the last question that we have before we break here is construction is a big industry, when we take the totality of it. It's over a trillion just in commercial, just here in the US. That's not including single family homes, which puts that, probably into the multiple trillions of dollars that is put into construction every year. And that's not even, considering finance and, all the other pieces that come around construction. That's just construction dollars. So, as big of an industry as it is, like anything, there's always some problems, but we also want to find solutions. So, what's maybe one of the big problems that you see with our industry, and how can we go about solving it?
one of the big ones is, and I'm sure it's something that's been on like everybody's mind is really the supply chain. And I know it's a tough thing to, it's a tough like egg to crack, and it's a big problem. And I think we could really look towards some of the big companies that are doing it right. Warehousing the right products, housing the right thing, having that kind of that last mile approach to like shipping. And I'm sure I would almost foresee that most of the bigger supply companies are thinking about this and like doing it, but until we really see it happening, it's going to be a problem for some time. So if anything, if we could help solve or help what eliminate and fix the supply chain, because it's really been a problem for some time now, and it only gotten worse during the like the pandemic. Um,
Yeah, I would agree. I mean, I think as more manufacturing comes back to the US, you're seeing silicon manufacturing coming back, and those plants should be online here next year, for chip manufacturing and a lot more manufacturing just coming back to the US. I think that'll improve a lot of the supply chain. Obviously, with so many things being so far out, all those plants have to come online. They have to come into full production for us to just get caught back up to where
yeah,
we can be in kind of a normal state. But I would, I think that is the big one. I think, the solution is really just keep building in America and, and bringing that supply chain closer to home is, I
yeah,
think, the message.
yep. And that's really going to help, I think, like the pinch points of the like industry. And take for instance like electrical gear, just getting that like on board. It's here's outrageous like lead times on a lot of this equipment, and it's just been really, really, really tough.
Any final words, Todd?
Just really, again, I really want to approach if we approach the projects like in a teaming approach. Huge fan of that. I think most people are, and yeah, just so again, if anybody is ever interested in in the profession, I also um, try to inspire young architects and young like engineers to look into the profession. We have a supply chain issue there as well. So let's see if anybody wants to step up, and we'd be more than glad to help them out.
Absolutely, guys. And Todd, thank you so much for coming on. I think that's a great message. We try to push that here quite a bit is, making the trades cool again is one of those things, and whatever form you want to come into the construction industry, we need you. Whether you
Yes,
want to be in the field, in the office, an architect, an engineer, um, contractor, we need kind of everybody through the whole life cycle of design and building and maintenance. I know a lot of facilities managers that are retiring and they would
it's a
like
growing
somebody
profession. Yes,
to come behind them. So thank you so much for coming on today, Todd. We covered a wide range of topics from electric vehicles, the grid, to automotive, to modular construction, and then again bringing people into the trades. And the big message here is, guys, work as a team. That's so important to getting a successful project across the line and having a building that you can be proud of at the end of the day. So, with that, thank you again, Todd, for coming on. And that's this episode of the Construction Corner podcast. Until next time.